Today we're going to talk about laser trimming of photonic circuits. Really a quick history of the company. The company was founded in 2017 by two Laval University students based on the short pulse 3-micron technology. And today we've branched out and developed applications for semiconductor and photonic integrated circuits, cleaning and trimming. We have fully equipped test labs. It's a complete solution from hardware to software. It's fully integratable into the semiconductor machines. So basically, the reason we're here is because Femtum is because the silicon photonic market is increasing. I'm not going to go. This is just one of the many forward-looking statements. The annual growth rate is very high. So basically, after a long wait of the silicon photonics, we know that the silicon photonics is now market of today. So let's just see what the market brings with this. So basically, since we're manufacturing photonic circuits, the photonic circuits themselves are more difficult to manufacture. Their process variations affect the spectral response in various ways. One of the reasons why this is the case is that the parameters, the work parameters or propagation parameters for the waveguides depends on the physical dimensions of the waveguide itself. So for some, this is a couple of 100 nanometer wide. So it's very difficult to be able to manufacture these. So what kind of situation are we looking at? If we're looking at a micro example here, at the wafer level, you see that the spectrum is variable, and the actual spectral response depends on the position on the wafer. So we have some kind of distribution of the resonances, which are the dips in the peaks here. So let's just take a moment to look a bit more into the details of this distribution and how it affects performance. So you have some basic three categories, so the pass or A grade, which are around the central design wavelength. Some are really way far out and are offset. And depending on what the commercial value is and what you want to do, the outliers might be B grades or might be fails. So typically at this moment in the PIC circuits, thermal phase shifters are used to compensate for this variability in manufacturing. But the thermal phase shifters, they bring some constraints also into the circuits themselves. So they can increase, this is a heat mechanism, so the local heat might be very high, which usually degrades the reliability of the systems and comes with increased power consumption. And plus the TPS require calibrations. So the goal here is to find a way and present a way to tighten a bit the distribution. So what potentially what we would want is we want the fail regions to be depleted and bring all these circuit responses to the design wavelength. And this is what PIC trimming does. And it brings some benefits with it. It brings bringing fail circuits back to the pass where they can be shipped. So it has an impact on revenues, of course. And plus, when you're looking at the effect, the TPS will remain in the circuits, but they're used in a less stringent way. So the localized temperature would be lower, and then you would have higher reliability of these devices. So there's some key requirements. I'm going to cover three of them today. The linearity of the response. I want to just make sure that I mention that everything is tested in-house at our headquarters. We have a fully equipped application lab. So we tested 3 unbalanced Mach Zenders, and this is the response we get. So we have the normalized the response, which is variable, And after trimming, we see that we can set the resonances to the target wavelength. And depending on the number of pulses that we use alongside the waveguide here, we get phase change that varies very, very linearly and extra attenuation that is very low. So linearity it's a key performance because it helps us to make quicker process in the end. Another key result is having a full pi shift. So we want to be able to recuperate all the different manufactured picks and being able to shift the spectral response by a half period enables this. So we can do this and bring the spectral response to the desired wavelength. These are really nice key results, but you might want to know how permanent these shifts are. Basically, we've tested some of the devices that we have in-house that we've gotten from customers and that we've gotten from partners. And we've done some shifting of the spectral response by some radians and even a pi shift. And after 500 hours at 125 degrees, we get this very repeatable result. This is the difference between after the annealing test and before the annealing test. So if there were any movement at the pi shift level, we would have a very big variations. And since it's independent of the actual phase change, this is a very good result. Demonstrate permanency. And you see that the insertion loss also does not move. So what's our main product? How do we get this done? We have the laser source, which is rack mounted. It's fiber based, and we bring it to the optical head, which was newly developed. The optical head has a high precision focusing optics, so we can have very precise beam sizes. It's a 2D galvanometer, so we have beam pointing. The imagery is included. And this is all supported by an automation software, which controls the laser, the motioning stages, the vision, and the data management also. So we launched this product at OFC. You see here the fully integrated machine, and this is an example of our application lab. And while we're talking about the application lab, I want to be able to discuss briefly about how we work with the customers. So phase one, we have the phase one, which is evaluating and optimizing the process. The trimming process requires some optimization depending on the PIC circuit. We will have either phase, pulse width, pulse duration, pulse energy that we can tailor to get the optimized results. So we get these tests in before you actually buy the products. So this is a good proof of concept here that we work together. So quickly in summary, we have the PIC volume is integrating. We have the trimming performance, which is we can get pi shifts. It's a low loss solution, but there's also some other parameters that we can tailor. We can talk about this in details when we contact each other. So as a bonus, I'm putting trimming video links and other products that we have. And we should see each other in Munich also, which is a great opportunity for us to discuss. And if you have any questions, just contact me directly.